Hello everyone, this is Siddharth here. Today we'll be discussing this last week's contest second question, maximum sum of an hourglass. In this we are to find the maximum sum of all such hourglass figures found in a given matrix. So yeah, let's take an example. So in this given matrix, if I were to iterate through all the elements, that would in a sense not make much sense. How I can do it in a bit more efficient manner is I just need to take care of my middlemost element of my hourglass formation. So let's consider this to be an hourglass. I'm given that the very three first elements would form my top part, and there would be a middle element, and there would be three different elements in my bottom part as well. So for iteration purposes, if I just take care of my middle element, then I can figure out how to iterate through my given matrix in a bit more better way. So I can see that this will form my very first hourglass. My another hourglass would be this, and similarly for the bottom part of my matrix. And I can see that this might seem to be a bit confusing, so one thing I need to make sure is that to not come up with the condition of overflowing or going out of bounds, all I need to do is I need to take care of my middlemost element. So I know that my middlemost element will always start at this very position at my given index 1 and 1, my x coordinate being 1 and my y being 1, and will always last at n minus 1 being my row and n minus 1 being my column, given that n is actually when we are considering one based indexing. Otherwise that would be considered to be n minus 2 and n minus 2. So yeah, and this would always be my last index. So yeah, in that way I can just iterate through my given matrix by only considering my middle elements and calculating the given sum consisting to these very middle elements, and then I can just compare it with my maximum element, and then I'll have my answer. So let's code this up. So first of all, I need to know as to how many rows I have. I can do that by calculating my grid size, and my total number of columns would be this. So what I need to do now is I just need to iterate through my given matrix, and I need to go till my roth index, an index less than my and I also need to increment my I. For my column I need to start from 1, and I need to go till 1 minus my total number of columns, and yeah, I can just have a temporary sum here. I need to have a result here. So yeah, that would equate to my sum of now I'll need to calculate the sum of my upper row, so that would be this. And I also need to calculate the sum of my bottom row. after that I just need to consider if this is actually greater than my current max, my current resultant, and that can be done in this way. I just need to return my result here. Let's see if this is working fine, and let's submit it, and it's working perfectly fine. So yeah, the given time complexity would be order of rows cross columns, because I mean I definitely am not iterating through all the elements, but that would be a very small amount, and in a sense that would be not considered. So yeah, I would definitely have a time complexity closer to that of order of rows cross columns. So yeah, that's perfectly fine. And if you like the video, please like and subscribe, and I'll catch you in the next one.